Magnets alter the space around itself and therefore influences other magnetic materials in its surrounding. Magnetic field lines help us to visualize the magnetic field of the magnet, which can be viewed using iron filings scattered about the magnet or by using mini plotting compasses scattered about the magnet. This is the setup in front of you. There is a pendulum rod, an adjustable gap magnets, and three aluminum blades. Up to two blades can be attached to the rod to oscillate freely. There is a full blade, there is a notch blade, and a slotted blade. Two blades can be connected at a time. Aluminum is non-magnetic, so there is no force of attraction when suspended between the gap magnets, as opposed to this iron wire lead, which is magnetic. Two blades are set up and are free to oscillate. With the gap magnet in place, will the magnet affect the motion of the notch blade? Set up the notch blade and release and observe. Now, will the magnet affect the motion of the full blade? Although aluminum is non-magnetic, the oscillation of the full blade motion is stopped by the magnet. The oscillation of the notch blade continues. What will happen to the slotted blade's motion? Now attach the slotted blade, release, and observe. In 1819, Hans Ørsted demonstrated that an electric current produced a magnetic field in an experiment similar to the one shown. Notice the compass needle deflecting in response to the magnetic field when the circuit is closed and a current is allowed to flow through the wire. In the 1830s, Michael Faraday's experiment demonstrated that a changing magnetic field in a conductor induces circular currents. The induced circular current produces its own magnetic fields that oppose the magnetic field of the magnets and therefore slows the oscillation. The blade must be moving relative to the magnets to induce the circular current. Once the blade stops, the induced circular current stops. Can you explain why the slotted blade oscillation ceases while the notch blade oscillation continues? Send your response to jonathan.williams@tri-c.edu. Explore magnetism and more in Physics 1220 or Physics 2320.